Okay, here's our review again. This is my second time. Like last test, I had to redo the entire thing also, so kind of a bummer. But oh well, what do you do, right? Okay, I'm just going to start with a couple things. Make sure you use your exam 3 formula sheet. Um, this will save you. And the other thing to remember that you can use is this magical thing. We can mostly use these. You'll also use your vehicle loan and your home loan. Where is that? Right there. Whoops, that doesn't look like yours. There you go. So you'll use these. You want to make sure that they're set up correctly. So like right in here where it says payment, you want to make sure it has payment, this payment formula in there and not just a number, or else it won't calculate correctly. So we'll be bringing that out in just a second. All right, here's number 1. I'm drawing these on here so maybe people can scroll through and find the ones that they need help with. Just kidding. We're not doing number 1. That's too easy. Number 2. That's our first one. Okay. And hopefully mine are ordered in the same order as yours. I think they are. I think they're not in a random order. So number 2 says, let me get to that one. All right, of the 43 people who answered yes to a survey question, 9 were male. Of the 41 people who answered no, 7 were male. If one person selected at random from the survey participates, what is the probability that the person either answered yes or was male? Okay, so this is where this magical formula sheet comes in, because it tells us if we hear the words either and or, we have two choices of formulas we're going to use. On this one, so what we need to find out is if they are overlapping events or non-overlapping events. So the first thing I'm going to do is figure out what are the events. So the events are, the events are what the answer is, like what we're looking for. So the events are either they answered yes, we're going to call that A, and are they male? It's really or are they male, right? We're going to call that B. So the question is, are these overlapping? Can they possibly answer yes and be male? And the answer is yes, they can. And so these are overlapping events. So we're going to use this formula right here. So let me just write that down. Okay, so we have probability of A or B equals probability of A plus the probability of B minus the probability of A and B, because these are overlapping. We don't want to include the A and B, that they're yes and male. Okay. All right, so let's just do it. Our probability of A, so A is the probability of them being male. First, we got to find out the total number of participants. So we have yeses and nos. We have 43 yeses, 41 nos. So that makes us a total of 84 people surveyed. Okay. Now, so the total number of people that answered yes, so that's our A, right? The total number of people answered yes is 43. So the probability of A is, I'll write it down here. Or I won't if my thing's not working. Oh my goodness. Seriously. I'll have to use my mouse for this one. It's having issues. So now it's going to be ugly, but okay, 43 out of 84. Maybe it'll work now. Plus, there it's going. All right, the probability of B. Probability of B is of them being male. So we had 9 males that answered yes, 7 males that answered no. So that's 9 plus 7, which is going to be 16 males. And that's out of 84. If it helps you, you can even write those numbers up here. We had 43 yeses. We had 16, 9 plus 7 males, okay? So that's 16 males. And then we're going to subtract the probability of someone being male and answering yes. Well, that's our first thing right here, that of the yes, 9 were male. So that's going to be minus 9 over 84. Okay, so I have a common denominator of 84, which means I just have to mess with the top. Pull this up. All right, so I just go, oh, well, let's use my mouse. 43, I moved my keyboard, plus 16 minus 9 equals 50. Is that right? It doesn't look right. 43 plus 16 minus 9. Oh, it is. Okay, so I get 50 over 84. And when I divide that through, 50 divided by 84, then I get 0.595, which is right there. So luckily on these, I know you guys have had so much grief on the homework with the numbers not matching, but these are all multiple choice. So yay. So that means you're not going to have, get it marked wrong because you were off by a thousandth or something. All right, we're going to move on to number 3. And so number 3, there are 13 members on a board of directors. If they must form a subcommittee of 4 members, how many different subcommittees can be formed? Again, we're going to use this magical formula sheet. I just think helps on tests are amazing. So this is one, like, imagine having to memorize all these. That'd be horrible. All right, so you have, we got to look at, now we're going to come down to this cool chart. So things, when you have these things where you're picking a group or, selecting things from a different group, you have 2 things. You have, well, 3 things that are, I guess, sorry, 2 factors that are important. You have to find out if you can repeat the thing and if order matters. So in this case, we have 13 members on a board of directors. If we pick people to be one of those, we cannot repeat, because you can't pick the same person twice. A person can't be 2 people at once. So repetition is not allowed on this. So I like to kind of write those down just to make sure I've got it. So I'm going to say, oh my goodness, my thing's weird. Sorry. Oh. Wow, this is going weird. Repetition. Something is really going wonky with this. Repetition not allowed. Okay, so repetition is not allowed. And then does order matter? We want to know, does order matter? In this case, there's not like a first, second, or third, or a president, vice president. There's nothing like that. So order does not matter. So I'm just going to write that really quick. Order does not matter. Okay, and so now we come over here, repetition not allowed, order doesn't matter. We are using this combination formula, which they give us right here. So this is going to be our formula. N factorial, R factorial, and minus R factorial. Okay, and your N is always your big number, your total number of people you're choosing from, and then R is your, in this case, your subcommittee. It's your selection. All right, so we just put those numbers in here. 13 exclamation point. This is super frustrating. Sorry, it's just gonna be sloppy because I can't get my little thing to work. Now this is going to be N minus R, which is 13 minus 4, which is 9. Okay, my favorite way to do these is on my calculator. And by the way, oh, my kids showed me how to, nope, sorry. Anyway, if your calculator doesn't have these, you can find an online calculator that does. But if you're looking for this little exclamation point button, the factorial button, this is the easiest way, is to go 13 factorial divided by 4 factorial. And because the 9's on the bottom too, I'm going to divide by that 9 divided by 9 factorial also. So you just divide by everything that's on the bottom. And I get 715. If you don't have that, then you can write these numbers out. 13 times, 12 times 11 times 10. This is 4 times 3 times 2 times 1. Well, I don't have to write the 1. And then this is 9 times 8 times 7 times 6. Here, let me write a couple more of these out. You can see that these 7 times 6, everything down here is going to cancel with all these 9 times 7 times 6 times 5 times 4, right? So then you could just do this part on your calculator. So if you don't have a factorial button, then you can do it that way. 13 times 12 times 11 times 10 divided by 4 divided by 3 divided by 2. I get the same answer, okay? But if you can find a calculator with one of those factorial buttons, it's going to be easier. Okay, great. Moving on to number 4. Okay, there are 150 people in your student ward. What is the probability that at least one of them shares your particular birthday? Okay, so again, we're coming over to this thing, and there is the at least one. Where is that? There it is. Probability of at least one. Let's write that formula down. Oops, just disappeared that. Is that a word? It's not. At least it's not used correctly. Disappeared is not a verb. Okay, so it's 1 minus the probability of the event not occurring in one trial. So for me to figure out what the probability is of it not occurring, this is actually not up here. This is up here, this 1 minus PA, probability of an event A not occurring. But if you just think about it, you can figure it out. So the possibility of someone, random person that I go up to at my church party, my word party, is going to be and them having my same birthday is 1 out of 365. They're one person and they can only have one birthday, and there are 365 days in the year. So that's my probability that one of them does have my same birthday. So I'm going to change that into decimal form. Okay, so this is 0.0027. Is that what it was? Sorry, I just moved that. 3. Okay, that's the probability that they're not. The probability, that they are having my same birthday. The probability that they're not going to have my same birthday is going to be 1 minus that. Okay, so I can do this cool thing on my calculator where I do a plus or minus. It changes that to a negative, and then I add 1. So now my possibility that they don't have my same birthday is pretty high, right? So my probability of them not having my same birthday, and I'm going to put this in this formula now, is 0.99726 something, okay? That's probably them not having my birthday. And then I have to raise it to the power of n. N is the number of chances I have of getting this. So in this case, there are 150 people that I get to choose from. Okay, 150 people is my n. So now again, I have 1 minus this number. So first I have to raise this to the power. Okay, don't forget to do that before you do the 1 minus, or you'll get lost. All right, you'll have the wrong answer. So this is this. I'm going to raise it to the 150th power using this XY button. And I get 0.66264. So that would be 1 minus 0.66264. And again, I can do this thing where I make that negative and then I add the 1. And I get 0.337 or 34%. Okay. So those are pretty easy, as long as you remember that you need to find the chances of it not happening and put that in there. And not happening is always 1 minus the chances of it happening. Okay, we're skipping the next one because it's easy. Just a word on these. Anytime you have to do interest, you you're going to use this. You can use that horrible formula, but who wants it? Not I, said the fly. Okay, so you can come to your financial toolboxes for some of these. If they want, like on this one, your debt interest. You can also go, like on this one, it's the vehicle loan, so you could go to your vehicle loan done. Again, on this one, just make sure that your payment is set up as a payment formula and not just a number, otherwise it won't work. And if you're not sure how to do that, you can go back to the tutorial. And yeah. Okay, so next, we're going on to number 7. Okay, suppose a math class has 26 girls and 21 boys. If 2 students' names are drawn at random from a hat with replacement, what is the probability that they are both girls? These are pretty easy, but I'm just going to work one of these through just so you can see how it goes. All right, so we have 26 girls and 21 boys. So we need to find the total number of people in the class. So that's going to be 26 plus 21. So 47 kids in that class. If 2 students' names are drawn at random from a hat with replacement. Okay, so this is the thing we're going to be looking at. We're looking at, this is an and problem because we want to know if it's going to be a girl and then a girl. There's only one way this is going to work out, a girl and a girl. If it's a girl or a girl in the next one, that would be different. But in this case, it's a girl and a girl. And so, and they are independent. No, sorry. Yeah, they're independent because we're replacing them. Okay? Independent means that the second outcome is not affected by the first outcome. So in this case, if we draw a girl's name out of a hat and then we replace it, then our probability didn't change. So that means it's independent. If we left the girl's name out, then that would change the probability of the next one, so that would be dependent. But on this one, it's independent, so our formula is just going to be the probability of A times the probability of B. So probability of A is a girl, so that would be, there are 26 girls, so the probability of A is 26 over 47. And then the probability of B is also 26 over 47 because we replaced the girls' names. So then I just come to my calculator here and I go 26 divided by 47 times 26 divided by 47. And whoops, that's not right. Let's try this again. 26. I might have to do it. It should work this way, but let's see. There it is. I must have clicked something wrong. Okay, so that's the right answer, 30%. Okay, so fairly easy. Just remember, you have to determine if they are independent or dependent. Does it change? Does your second event change because of the first event? All right, now we're going to do number 8. I hope I don't run out of time. I got up at 5:30 to do this. I hope you guys all feel sorry for me. Actually, I know probably a lot of you get up this early all the time. I actually get up this early all the time too. I just wasn't planning to have to re-record this. But anyway, so I just have to get done before I have to get my kids up. Okay, number 8. You are checking out refinancing possibilities for your home loan. Tells us what the principal balance is and considering the pros and cons of a 30-year mortgage at this interest and 15-year mortgage. We need to find the difference in total interest, okay? So I'm going to use my awesome I'm going to try to use my awesome spreadsheet over here. There it is. I couldn't get it dragged over. Whoops, that's not it. That's our groups. Oh, it's already here. Just kidding. Okay, so we're going to our home loan. All right, again, remember you've got to have a payment set up in here or it's going to screw things up. All right, so we have a balance of 2,000. We're going to ignore these top numbers. And even though this loan amount in my formula is calculated by here with those numbers, I can just put a number in here. Now, when you exit out of this program, your financial template, you want to don't save it because you don't want to change these formulas that you worked hard to get. I gotta get my keyboard out. Sorry. Okay, so in this case, I'm putting in 200,000. One more. There we go. Is that right? Nope, that was 2 million. Sorry. One too many zeros. It'd be fun if you got to buy a $2 million home. Of course, payments would not be fun. All right, so APR is going to be 3.25. Loan years are 30. My payment there is accurate. So my total interest is going to be $113,000. That's a lot, right? I wonder if I can paste this in here. I think I can't, but no. It was a nice thought. Okay, so let me just write this in here. Even though I'm just going to, actually, this was my trick on this. I put it on my calculator. So I'm just going to put that number right into my calculator and hold it there. So 113,348.55. That's the total interest I'm paying on a 30-year mortgage. Now I'm going to check out my 15-year mortgage. Same loan amount. APR this time, oh heck. Okay, APR this time is going to be 2.85. My loan years are going to be 15. Now my payment goes up quite a bit, but now I'm only paying $46,000 in interest. So I'm just going to subtract 46,020.53. And I get 67,328. Now notice that my number's slightly off here. That's because I didn't round, or they didn't round, or they used a payment formula, and I don't know what. But it's close enough, and that is a correct answer. So again, luckily it's multiple choice. So yeah, so just go ahead and use that. And then remember that when you close this, don't save these values because then you'll screw up your chart. All right, we're going to put my keyboard back. You guys can't see what I'm doing, of course. We're going to do number 10. All right, so skipping number 9, going to number 10. All right, imagine that you are judging a pageant and you need to select 3 winners, a queen, a first runner-up, a second runner-up from 10 final candidates. How many outcomes are possible for the 3 winners? All right, we're going to come back to this cheat thing. We want to know if repetition is allowed. Again, whenever we're choosing and we're trying to find the number of outcomes, we're going to use this little table. So is repetition allowed? Can one person be in the queen and the first runner-up? The answer is no. And so repetition is not allowed. And then does order matter? Yes, it does. It matters, really matters to the girl who's the queen or not the queen, right? And then the first runner-up, second runner-up. So order matters. So we're going to use this permutation formula here, which is sorry, let me move that over just a little, then I can see it. And I'll try using my thing so it's not ridiculous. Over n minus r. Okay, again, n is going to be 10 in this case. That's the number we're choosing from. And then r is going to be the number that we actually pick, which is 3. Okay, so then I have 10 over 10 minus 3, which is 10 over 7. Okay, so then I just can use this 10, that factorial divided by 7 factorial. And I get 720. It's kind of incredible that out of 10 people and 3 slots, there are 720 different things. It's amazing. Okay. So that was 10. We're going to do 11 next. We'll start skipping more because they start getting repetitive. Okay. An insurance policy sells for $730. Based on past data, the company has computed the following probabilities. an average of 1 in 60 policyholders. Oh no, I'm yawning, excuse me. Sorry, I'm tired. We'll file a $10,000 claim, blah, blah, blah. We have all these numbers, okay? We need to find the expected value. This does not tell you how to find expected value. You just have to remember that one. But it's okay. Oh, just kidding. It does. Look, it's right there. And it's easy. It's just the event value of 1 and the event probability. Okay, and then you add them all together. Yeah, these are awesome. I get kind of irritated with math classes where they don't let people use formula sheets. I mean, sometimes it's necessary, but these are not formulas you need to have memorized. You can find them somewhere always. So I'm really happy with this class that they give you this formula sheet. Okay, so what we're going to do is we're going to find, it's 1 in 60. Whoops, not 1 in 16. Okay, 1 in 60 times 10,000, right? Plus 1 in, goodness, I am losing my mind this morning. 1 in 120 times 20,000 plus 1 in 300 times 50,000. Okay, you can do this all in your calculator. If you are uncertain and you have a difficult calculator, I mean like not a complicated calculator, a very basic calculator, you might want to do each of these individually and write the numbers down and then add them together. But most calculators you can just do them all. So you're going to do each one of these separately. So it'll be 10,000 divided by 60 plus, and if you have a good calculator, it will just combine these together. It won't screw up your thing. Plus 20,000. Is that 20,000? Divided by 120. Plus 50,000 divided by 300. Okay, so my the expected value of this policy is going to be $500. I mean, they're going to end up spending on average $500 per person on this policy. Okay, so if they sell it for $730, then my expected value, the expected value that they can get from the policy is $230. Okay, and that's going to be positive for the company. So they want to know the expected value to the company. If it was expected value to me, then it would be negative because these, so right now these are all negative values because they're what the company's paying out. 730 is what they're getting in. Okay, so some of these negative values matter, but in this case the company is making a profit, and so it's going to be a positive. Okay, now we're moving on. We're going to skip a few. Skipping all the way to 17. Oops, we'll go to the question menu. That will be much faster. Okay, question 17. All right, you have a 10-year student loan of $8,000 with an APR of this. If you take the entire 10 years to pay it off, what percent of your total payments will have gone to interest? Okay, this one we're going to use, I wish I could remember what, I think I used a payment calculator. So we come to the financial toolbox, we're going to figure out our payment. So I'm going to go APR of 6.5. Need my keyboard again. APR of 6.5. It's compounded monthly. Present value is 8,000. Future value is 0 because I will have paid it off, right? And it's going to take 10 years. So my payment is 90.84. Okay, so I'm just going to write that down in here because that's as much as this is going to do for me. Actually, there's another calculator anyway, I think there's a way another calculator you can use, but this is going to be 90.84. I'm going to pay this every month for 10 years. So times 12 times 10, right? So the total payment on this is, let me get out my calculator, 90.84 times 12 times 10. My total interest is going to be, my total amount that I've, oh, gee, I don't know why this is doing that. Did you see that? I think there's a magnetic something, like maybe I think my headphones have a magnetic thing on part of it that is making it like drags across there on the cord. I don't know. I can't figure it out, but it's super annoying. All right, you can't even read that. Let's try this again. So the answer down here is that. That's how much total you're paying on the loan. And so then you would just subtract your you can subtract the price of the loan, which is going to be 8,000. I think I used a calculator for this one. One of these. So anyway, that's going to be your total interest that you paid. They want to know the percentage that went to interest, and so you're going to divide that by 8,000. Oh, I did that wrong. Sorry. let me go back. Total interest. Oh, it's not by 8,000. It's the percent of our total payments that have gone to interest. So here's the total amount that we paid. 0.8. Sorry. Whoops. Sorry. Wow. I'm having a bad time on this one. So that's how much total we paid for the loan. I subtract the principal, which was 8,000. That gives me my interest. So it's going to be total interest divided by the total number I paid. Sorry, not divided by the total amount of the loan. They want to know the total number that I paid. So sorry about that one. There we go, 26.6. Okay, so sorry, that was a little confusing. Just remember that it's going to be your total interest divided by total paid. Okay. Okay, moving on. Hopefully the next one will be less messy, right? Especially because it's almost time for me to wake up my kids. I got a lot left to record. Next one I'm going to do all right, I'm going to do the Powerball one because I think that is a little confusing. I saw some people getting off on that one. So that's number 21. Some people were a little confused by that on the homework or on the discussion. All right, in the rules for the lottery game, Powerball game, whatever, you choose 5 unique numbers and then the Powerball number. Okay, so what we do with this, we're gonna first, oh, here it went. Couldn't find my formula sheet. All right, so we need to know, we're going to be dealing with either permutations or combinations. We're going to look at these numbers separately. We have our 5 unique numbers. So that's 5 numbers that are unique. Unique is an important word that tells us they don't repeat. Okay, right? And then we have our Powerball. And there's only one way of getting that because it's only one ball, right? So they don't unique. Oh, they're unique, and they can be in any order. So they don't repeat, and order doesn't matter. They don't repeat, and they can be in any order. So order doesn't matter. So what we're looking at for this one is repetition not allowed And order doesn't matter. So we're looking at this combination again. All right, so the combination formula, once again, is, all right, so in this case, n is going to be 59. I have 59 numbers to choose from, 1 through 59. And then the last one is going to be, and then I'm sorry, R is going to be the 5 numbers that I'm choosing. And then the Powerball, I'm going to multiply this answer by the odds of the Powerball, which is just 35. Okay, I have 35 choices. There's no factorial on it. It's just a straight up 35 because there's only one ball. Okay, I have 35 chances to get that number right. Okay, so now we just do the math. 59 factorial over 5 factorial over n minus r. So 59 minus 5 is going to be 54 factorial, right? And then that's also going to be times 35. Okay, so I come over here, I go 59 factorial divided by 5 factorial divided by 54 factorial. Remember, you're just going to divide everything that's underneath. Equals that times 35. So I have a 1 in this giant number, 175 million chance of winning the Powerball. Okay. Okay, so just remember to look for those keywords like unique and in any order. Those are important. All right, next we're moving on to, I think we only have a few more. This one I'm not going to do the whole thing. We're going to 23. I'm not going to do all the calculations. I just want to remind you of something important. Okay, so on this one, you're going to fill out this little table to find out the final balance right here. Remember that what you're going to do on here is you're going to find your balance or your interest by multiplying the interest rate by the balance, the previous month's balance. Okay, so some people got confused and they calculated a balance here and then they multiplied the interest, and it can't work. You pay interest on the previous month's balance. So, and then the other trick on this, and this one it breaks it down, but if it gives you, in this case it gives you, it tells you the monthly interest rate. They told you that it's 1% per month, so that's the APY is actually what that is. I don't know what they call it, the APM, like month, right? But it's the APY is 1%. That's the number that you have to use. So if they only give you an APR, like if in this case, if they only told you that the APR was 12%, you would want to divide that 12% divided by 12 to find your APY. So in this case, they told you what that was, but just watch out for that. So for me to find my interest on this first one, I'm going to have my previous month's balance times 1%, which is actually going to be 50, right? I'm sorry, 5. Okay, we're going to move it 2 places. Okay, so that would be $5. So my interest is going to be $5. And then I'm going to take my balance and I'm going to minus my payment. And then I'm going to add back in my expenses and my interest. Okay, so like on this first one here, you would have 500 times 0.01. That gives me $5, right? That's my interest. So then we'd have 500 minus my $120 payment plus my $160 in expenses plus my $5 in interest. My new balance is going to be $545. So I'm not doing a very good job paying this off. Okay, so and then you'll do that for all of the months. Excuse me. And you'll have your answer at the end there. Darn, I don't have any water in here. All right, let me move on to number 27. We're getting there. Oh, actually, I'm not going to do 27. 27, you can just use your toolbox. So that one's, well, I'll just show you. It's so fast. If I can find my, there it is. On this one, you're going to use the future value toolbox. Hello. Okay, there it goes. Or I'm sorry, the present value toolbox. If they, the maximum monthly payment you can afford is $100 per month over 5 years. So if you go to your present value tool, they want to know, determine what your maximum loan amount can be. So APR is 4.5. Compounds is 12. Future value is going to be 0, right? Because you're paying off your loan. Your payment is going to be $100 a month over 5 years. So the maximum amount of loan you want to get is that. So this is a really, really cool tool to figure out, like when you know I have this much I can spend on something, and so that tells you, like if you wanted to get a car, that'll tell you how much money you could afford to finance on your car. So pretty cool tool that one is. All right, let's see what's next. Okay, we're going to do 28. Just kidding. I think we're not going to do 28. I'm going to walk you through 30 just a little bit. And then there's just a couple more we're going to do. All right, 30. 20, it's easy. It's just the probability of answering things is multiplied by itself. Okay. 30, this is kind of like the lottery thing we just did. How many 6-character passwords consisting of numbers and lowercase letters are possible if the last character must be a number? So the trick on this one is, so we have 6 characters. And I'm not going to do all the calculations on this, but except the last one's going to be different, right? So the first 6 characters can be, or first 5 characters can be either a lowercase letter or a number. So there are 26 choices for our letters, and then there are 10 choices for the numbers. Don't get confused by 9 because you can use 0 as one of your numbers. So you have 0 through 9, which gives you 10 choices for your numbers. So don't get confused by that. So our total number of choices for the first 5 slots is 27. Okay, and then so we're going to work that part of it separately. We're going to have, I'll just work it out. So it says, so it doesn't say anything about repeating or an order matters. So repetition is allowed. Order does matter because we care. We're not just randomly picking them. We care what order they're going in. And so repetition is last reason n to the r. So in this case, our n is going to be 27, and our r is going to be 5 because we're just going to do the first 5 numbers at once. And then the last one, the last character just must be a number. So we're going to have n to the r, times our last number, which is a choice of 10. Okay, so this is going to be 36. Whoa, did I just say 27 on this one? Sorry. Answer here is going to be 36. Sorry, you guys are like, wow, how did you get that? Okay, so it's going to be 36 to the 5th times 10. Okay, so you guys can figure that one out the rest of the way. All right, let's go quickly and look at number, I'm out of time really, but I want to hurry and get these for you. Number 33. I didn't write that very big, did I? Okay, on this one, the probability of getting a sum of either 4 or 7 on a roll of 2 dice. Okay, so on, again, we have an either or thing here. So we're going to actually and it's non-overlapping. You can't get a 4 and a 7 at the same time. So it's going to be probability of A plus probability of B, okay? And then there's no, you don't have to do the subtraction thing there. All right, so probability of getting either a 4 or a 7. What you have to do, you have to know the probability of getting any one number on a set of dice on two. If you roll 2 dice, is always 1 out of 36, because there's 1 out of 6 for the first die and 1 out of 6 for the 7th. So when you're rolling 2 dice, your probabilities for any given combination is 36. So what we need to do is find out what my choices are for finding 4. So I can get a 4 with a 1 and a 3, with a 3 and a 1, and with a 2 and a 2. Now, technically, I have another chance at a 2 and a 2, except they count these the same because you don't really know which dice it is. So we don't count this exact same thing. So there are 3 ways out of 36 to get a 4. Okay, then to get a 7, I can have 1 and a 6, and a 6 and a 1, a 2 and a 5, and a 5 and a 2, a 3 and a 4, and a 4 and a 3. So there are actually 6 ways to get a 7. And so then I'm just going to add those up. 3 over 36 plus 6 over 36 gives me 9 over 36, which is 1/4, which is 25%. Okay, so just remember these rules, that if you're rolling 2 dice, you have 1 out of 36 chance of getting any combination. All right, going to number 36. We're going to just look at this really quick. This is another dice one, but this one was a little confusing to me. Like I was thrown off because it seems like it should be harder, but it's not. Okay, I guess it's only a 3% chance, but all right. In many board games, you're allowed to take another turn if you roll doubles. What are the probabilities could happen to you 2 times in a row? So the probability of rolling doubles once, remember our probability for dice is always, or for 2 dice, is always 1 out of 6. Okay, so I have a 1 out of 6 chance of rolling doubles. And it's just, I don't have to get the same set of doubles. I can get double 2s and then double 4s, okay? So I have 1 out of 6 chance of the first one. And so this is an and they are independent events, because my first roll does not affect my second roll at all. So probability of, so that's 1/6 times, the probability again is 1/6. So I have a 1 out of 36 chance of rolling, and that, if I do the math, is this number, of rolling doubles twice in a row. Okay. Ooh, this is the last one, which is good because it's time to wake up my kiddos. All right, this is number 39. Oh, what happened here? Oh, here we go. That looks lovely, doesn't it? And if this didn't record, then I don't know what I'm going to do. I'm going to be really mad. I checked my sound like 4 times. So, all right. This one is not hard, but I was making it harder than it was. So just in case you're like me and you made it harder, let me show you how to do it. Suppose you have a box of 8 crayons. Without looking, you take 3 crayons from the box without replacement. Then you replace the crayons and your friend does the same thing. What is the probability that you both choose the same 3 colors in the same order? So in this one, I was trying to figure out my probabilities and the probabilities of my friend getting those exact same crayons, and so I was multiplying the 2 probabilities together. But guess what? The probability of me choosing a crayon out of a box is 100%, because it doesn't matter what crayon I'm choosing, it's 1. And then my probability of choosing the next crayon out of the box is also 1, because it doesn't matter what I choose. So my probabilities are 1. It's 100% that I'm going to choose 3 crayons. So it doesn't matter. My friend's probabilities then do matter, because say I chose a red and a green and a purple, then she has to choose the same exact crayons. So she has a 1 out of 8 chance of choosing a red. And then the green is going down. So we're over here with dependent events. Okay, so that means the probability of A times the probability of B, subtracting the A out of there because I didn't put the crayon back. So now I have 1 out of 7, and now I have a 1 out of 6. So I do that math and I come up with that number right there. And these are multiplying, remember, because we've got an and. They have to choose this and this and this. Okay, so all right, that's it. Hopefully this was helpful. Good luck on the test.